Hello there, Year 9s, Mr. Herman here. This is exercise 7b, sketching parabolas using transformations. Learning goals for this lesson is to know the types of transformations, which includes dilation, reflection, and translation, to understand the effect of these transformations on the graph of y equals x squared, and to know how to determine the turning point of a quadratic wall from turning point form. The success criteria is to be able to sketch a quadratic from turning point form. Apologies if you heard some beeping in the background. I'm not too sure if that got through to my microphone, but that was the dishwasher. So sketching parabolas using transformations, we've already seen the different types of transformations that you can encounter when it comes to the basic form of y equals x squared. We can see a dilation when there's a pro numeral in front of the x. You can see a shift either left or right, depending on if x is with a numerical value within a bracket, or you can get a translation up, down, if there's an attachment after the x squared, and you can also get an inversion if there's a negative number in front of the x. So we're going to be looking into drawing parabolic curves by saying the turning point, the axis of symmetry, and where the y-intercept is. We'll break down the different types of changes that you can make on the generic y equals x squared graph. For y equals ax squared, the letter a, so the coefficient of x, dilates the graph. So it can either, remember in the previous one, it can either stretch it out like that, in comparison to a generic parabola. You can stretch it out, so if a is in between 0 and 1, that can stretch out, or if a is greater than 1, you can accelerate at a fast rate, so it becomes narrower or squishier. Your turning point will still be at 0, 0. Your y-intercept and x-intercept again will be at 0. Axis of symmetry will be at x equals 0. When a is greater than 0, it will be upright. When it's less than 0, or when it's a negative number, it will do the opposite. It will be inverted. So that's the first type of change or shift you can have. The second one is for when we have y equals x minus h, and the minus h is within the bracket of squared. H translates the graph horizontally, so it can either shift left or right, depending on what the sign is and how many units. So when h is greater than 0, the graph is translated h units to the right, so it would follow the x minus 3, so we go to the right 3 units. So when there's a minus, it goes to the right. When it's a positive, or when h is less than 0, this will take on a positive number because it will be 2 negatives, makes positive. This will be translated h units to the left. So in this example here, this is x minus 3 all squared. This goes to the right 3 units, and so our parabola looks like this. When you have a k or a constant that's added or subtracted after the bracket, it's not associated with the x squared, this changes the y equals x squared graph vertically. So again, it gets shifted up or down. When k is greater than 0, it will go up, and when k is less than 0, it will go down, depending on what that k is. So it will be translated k units. Now the generic type that you can get is this format here. There's a lot of letters going on, but these are the 3 things that you could be given within a graph. You can get A, which is a dilation. You can get K, which is a transformation left or right, or you can get K, which is a transformation up and down. A, H, and K will always be replaced with a number of some sort, and that number can sometimes be 0 for H and K, and that number can always be 1 if it's for A, but you will always follow this type of format. Now with this format, A equals A x minus h all squared plus k. I thought I'd just write it again. To find your turning point, just get whatever the h value is and whatever the k value is, that will be your turning point. So where it reaches either a minimum turning point or a maximum turning point, depending on if it's inverted or not. And your axis of symmetry happens at wherever h is, whatever the value of h is, assuming it follows this format. To further look into this, we're going to look at 3 different examples here. We're going to sketch these transformations. Now, I luckily have the luxury of just having these graphs already provided to me from the textbook, so I can show you what's going on. You would just go ahead and use graph paper or some type of gridded paper. Hopefully you do have some, or you would just rule up your set of axes and draw to the best of your ability. So here we're going to sketch the following graphs, and we're going to be labeling the turning point and the y-intercept. So the first one is y is equal to 3x squared. So this is just like your normal y equals x squared, but it is being dilated because it's a coefficient in front of the x squared, and this number being 3. Our turning point will still just be at 0, 0, x and y-intercept will be at 0, 0. So we'll follow this graph here, and we're going to put x is equal to 1 just to label a second point, just as some type of reference. And when you substitute x equals 1 into here, you will get a y value of 3. So this is where this 1, 3 comes from. So this is the basic concept that you will need to adhere to in order to sketch a y equals 3x squared. For y equals minus x squared plus 4, there are 2 things going on. The first one is we're dealing with an inverted parabola. Because this number is the coefficient is a negative number, -1 namely, we're going to flip this upside down, and it's being shifted 4 units up. So 4 units vertically, this is going up. So our turning point would be at this point right here. And it has a maximum turning point because it starts from the bottom and goes up, reaches the maximum point that it can get to, maximum turning point, and then goes back down again. The turning point is 0, 4, and the y-intercept, so when x is equal to 0, is equal to 4. So effectively it's the same place where the turning point is. If you substitute x equals 4 into here, or x equals 0 rather into here, you will get a y value of 4, and this is where that 0, 4 occurs. For y equals x minus 2 all squared, we have a shift or translation 2 units to the right. Because this is a minus, it goes 2 units to the right. There's no dilation and there's no vertical translation of any sort. This has a minimum turning point because it starts up high, it goes low, it goes to the lowest point of 0, 2, or 2, 0 rather, and then it goes back up again. So the turning point here is 2, 0, and to get your y-intercept, you're going to substitute x equals 0 into this equation. 0 minus 2 is -2, -2 squared is positive 4. So this point here is x is equal to 0, y is equal to 4. So sketching these graphs are quite simple as long as you know what type of shifts are happening and what type of dilation is happening and whether there's a reflection or not. Last 2 examples, we're now going to get into a bit more in depth of the different types of parabolas that you can get. Here again we're going to label the turning point and the y-intercept. So first one, we have y is equal to x minus 3 all squared minus 2. Okay, so let's see what's going on. We have 2 types of translations. The first one is that the parabola is getting shifted to the right 3 units. It's going to the right 3 units, and then it's also going down 2 units. So shifted to the right and then going down, meaning that this turning point that occurs is at these 2 values, hk. Because this is x as in the x minus format, we can say that a turning point is at 3 and -2. So 3 units right, 2 units down. So our turning point, our minimum turning point, is at 3 minus 2. Where the y-intercept occurs, so where the graph hits the y-axis, we're going to substitute x equals 0 into there. By substituting this in, you end up getting 0 minus 3 all squared, which is -3 all squared, 9, 9 minus 2 excuse me, gives me 7. So this point right here, the y-intercept is 0, 7. The last one here, I've just written the equation here. Y is equal to negative x plus 1 all in brackets squared plus 4. So firstly, this is inverted, so this is flipped around from your normal parabola. The second thing is that we are moving to the left 1 unit. Because this is a plus, we're going to the left 1 unit, and we're getting shifted up, because this is a positive, 4 units. So I think the trickiest thing is knowing that when this is a plus, we're going left, and when this is a minus, we're going right. But then it doesn't really necessarily occur when it's just a constant at the end. That's probably the trickiest thing to grab or grasp. I guess even for me, when I was in year 11, I was just getting my rules confused. So just be careful of this. This gets shifted 1 unit to the left and 4 units up. So my turning point is at -1. Is at -1 and 4. This is because we have to put a negative because this is a plus, so it's -1, and this is just a positive, so it is 4, which you can see here. Again, if we want to get a y-intercept, if we substitute x is equal to 0 into here, we get 0 plus 1, which gives me 1. 1 squared, 1 times 1 is just 1, but then we have this negative that's just hanging out in the front, that's not associated within the brackets. So our answer becomes -1. That's where that -1 comes from. Then we're just simply adding 4, and this will give us 3. So when x is equal to 0, our y value is equal to 3, and that right there is your y-intercept. Then you just go ahead and sketch the parabola as normal, just making sure when it's that it's inverted. So just make sure, a little trick that I use, that when you have something that looks like this, x squared, this is a positive, so your parabola looks like this, which is a smiley face. It's happy. And when it is negative, so y is equal to negative x squared, it's sad. It's a sad face. Pretty silly. It's pretty late. I'm recording this really late, so if I sound delirious, it's probably because I am. Alright guys, best of luck for exercise 7B. See how you go, and I'll catch you guys in the next video. Tell you all.